of the latest. Also talk about the launch of the latest version of WinDriver, which is 16.5. If we haven't met before, my name is Nina, and I am Technical Account Manager in Django WinDriver. And today for this webinar, I'm joined by Uriah, who's our WinDriver R&D team lead. Uriah, say hi.
Hello to everyone.
Before we start, if you are a WinDriver customer and you haven't updated yet to the latest WinDriver version, we strongly recommend you to do that. And if you need help upgrading, do not hesitate to contact us. We'll help you. You can see our email right here. It's sales@django.com. If you have any questions regarding updating your project to the current version or obtaining WinDriver license or technical questions, reach out and we'll make sure to help you. And yeah, I think we can go ahead and start.
See that, sir? This is the first one.
Now I see the right slide, so we can go on. Let's take a look at what we will be discussing today. We'll start by a short overview for those who don't know what is WinDriver, how does it work, what is kernel module. Then we'll go over top WinDriver functionalities. Then Uriah will show us demo with the latest version, 16.5. And then we'll talk about the latest version, what's been added, what are the new features, and latest additions. Okay. So if you haven't worked with WinDriver before, WinDriver is a driver development toolkit that generates a skeletal code that's specific to your device. It supports any USB, PCI, PCIe devices, regardless of the manufacturer. And it works with mini PCI and Thunderbolt devices as well. It's suitable for Windows, Windows ARM, Linux, Linux ARM, and Mac OS. And we lately added RTOS Zephyr beta on our website. So if you're working with RTOS Zephyr, make sure to go on our website and check it out. WinDriver has enhanced support for various chipsets from Altera, Xilinx, and Lattice. And yeah, so let's take a quick look at how your workflow with WinDriver would look like. You would connect your device to your computer, you would open Driver Wizard and generate a skeletal code. Then you would modify the code according to your project requirements. You would compile it, run it, and here you go. You have a driver that is ready to be distributed. So let's take a look at what happens behind the curtains. How does it work? In user mode, your application uses WinDriver API functions to call low-level kernel mode functions. The bridge between user and kernel mode is handled through the driver INF, executing functions in the kernel and interacting with the hardware with the device INF. This architecture is what keeps things efficient, secure, and flexible. WinDriver supports multiple programs at the same time, enabling connection to multiple devices at the same time. This allows flexibility for complex automation setups and multi-board systems. Now, let's go over WinDriver top functionalities. What is that WinDriver can actually do? So with WinDriver, you can read and write to your device. What does it mean? It means that once you connect the device to your computer and you open Driver Wizard, you can communicate with your device within the minutes of work. Driver Wizard has built-in interrupt handler. You also can perform direct memory access. And moreover, we have direct memory access samples for various cards. And I'll talk more about it in a few minutes. What WinDriver also enables you to do is to generate files in CMake, which simplifies cross-platform development. because this way you can generate an app for Linux, and by doing minor changes and recompiling it, it's going to work for Windows as well. And also WinDriver allows you to implement kernel plugins, and we'll cover that one more in depth in a second. Okay, so let's take a quick look at what kernel plugin is and how does it work. Kernel plugin allows critical driver code to move into the kernel while keeping most logic in user mode. What it does, it improves performance without needing extra kernel debugging, and it is also offering the speed of kernel execution with user mode simplicity. Now let's take a look at what IP samples for direct memory access we have. For Lattice, we have samples for Certus Pro and Avant. For Xilinx, it's XDMA and QDMA. Those are the most popular ones. We also have samples for BMD. For Altera, we have Avalon MM Scalar, and Uria will cover that one because it is a new one. We have just added it for the latest version, as well as MCDMA and mSGDMA. And we also have samples for Xilinx. Mind you, all of those include code customization, so you can still adapt them to your project requirements. I think now is a good time to take a look at the demo and see how WinDriver works, how the magic happens. So Uria, over to you.
Hello, everyone. And I'll be sharing my screen in a moment with a running version of WinDriver. Just a moment. Okay, so are you seeing that? Okay. Okay, so I've just opened up the driver wizard of version 16.5, and I'm going to quickly create a new project with a device called EDU or EDU, sample device coming from a quick emulator or EMU. And it's a good device to exemplify the things that WinDriver does in a simple and quick way. So that's why we're going to do it. So when WinDriver wizard opens, this is the window you see. And then I want to create a new project. I see all the devices connected to this computer over here. And I'm going to choose this one because it's the one that I'm interested in. As you see, it already has an INF installed for it. So we won't need to install one, but if we do need to install one, we can just do it from here. Just click generate INF and decide which parameters we need to change, the name, whatever, pre-allocation of DMA buffers, if you want to support MSI interrupts or not, and so forth. But since we already installed it before the webinar, then it's already here, installed. So just like Nina mentioned in her presentation, you could see that we have the driver INF, which is just called WinDriver 1650 in this case, which is what happens when you just install WinDriver. And you have the device INF, which just gives you the information about the device, like the name of it, and requiring driver. So this is a dependency of this. Usually, if you only have one of these, then you know something's wrong. So, like if you're trying to work with a device and you only have one installed, then you should create an INF for your device, first of all. So the first step we already did for you in this case, but we just choose it, generate INF, and then we can click next. Now it's going to ask us to choose a demo name, or sorry, project name. So I'll just call it demo 5 for this sample, and the device is going to be opened. So practically in the driver wizard, we can see everything that all of the resources that the device has. First of all, the configuration space, and like all the registers in it, including like reading all of them and Some of them have like special interpretations, so we also have it in the details area here. And these can be very useful for debugging. If you know what they mean, I can just tell you that today we had a very interesting issue where we had a very interesting issue with someone trying to someone having a problem with DMA on their device, and we looked very deeply inside of the command registers and the link status registers, and finally we found out that some bit was off, and that was like a hint that something's wrong. So these could be very important sometimes, but it's very easy to overlook. So it's all available here without practically doing anything. And then we have the memory bars. And the memory on this device, we only have one bar, which is bar 0. So what I'm going to do with this bar, you can just read and write memory without like any, again, according to what's defined there, you can just read and write memory from the bar. But I'm not going to do this. Instead, I'm going to add an access register, which is a register that allows me to give it, first of all, it allows me to give it a name. So I'm going to call it raisins, because this register will allow me to raise an interrupt later. And how do I know that? Because this is a special device that has a register in offset 60, which if you write something to that register, then an interrupt is getting raised. That's just how the device was made. So once I made this register, what's nice is that the code, the generated code that I'm going to generate later will also include this register. So I can create as much registers as I want, and then I'll automatically generate code that includes all these registers inside. I'm not going to get into it now, but we also have the predefined action flows here, in this area, and it's pretty similar to what we have here, but in the PDA or predefined action flows mechanism, we have a similar thing, which allows us to not just create these registers that you can read and write from, but you can actually create flows of reading and writing, like, let's say, like a macro, or like this flow where reads and writes happen one after the other, and then the wizard does that, and then you can also generate the code, and the same like a flow also appears in your code without having to actually code anything. So that's a very nice thing. Another nice feature here is the import registers button, where you can actually import like a CSV file if you have like, I don't know, 100 registers in your device that you've already defined. You can just put them in a CSV file or export them from Excel into a CSV file, and then import them using this button. And then you could get a long list of a lot of things and a lot of registers, and then everything will be just automatically programmed into your generated code. So it's much easier to program this way instead of wasting time on actual programming if that's not your strong suit. Okay, so this is the bar area. And now we have the interrupts area. In the interrupts area, what we see is that we have this interrupt. It's an MSI interrupt. The operating system gave it number 8. And what we can do here is we can add transfer commands. Transfer commands are commands like, again, these are transfers that could happen when an interrupt occurs. So let's say I want something to happen after an interrupt occurs. I can add a transfer command. It will appear here, some kind of read or write somewhere, like an acknowledgement. And when I click, when the interrupt is raised, then the wizard will actually do that transfer command. And again, it will also be generated in your code afterwards. So that's, again, a very nice way to avoid actually writing code. It's just adding these transfer commands or removing them if you want to remove something from the list. But for now, to keep it simple, I'm just going to click on listen to interrupts. And now we're listening to interrupts. So if I go back here and I write any data to this register, let's say I just write, I don't know, 1. And then we see that we wrote to bar 0 at offset 60 the value of 1, and we got an interrupt. So actually, the interrupt handler actually did something. Actually obtained something, and the only thing it did in this case was just print it out that it got an interrupt. Now I'm going to generate code. So I want to go over this window of the code generation to cover a couple of things. So first of all, you can choose which language you want to generate the code for. So usually most people that work with drivers prefer C, and that's understandable because C has the best performance, but C is not the easiest language to learn. So if you are not that strong with C, you can also choose C#.NET, .NET Core, which means it's a cross-platform version of .NET, which works on all platforms we support, Windows, Linux, Mac, and so forth, x64, ARM, and so forth. We have the C#.NET GUI application. If you prefer actually creating a Windows GUI application, then this is the option for you because it gives a nice GUI, but it's only working on Windows because it's based on Windows Forms, which is not really supported on other operating systems. You can choose Python 2 or 3, and that's great if you want to integrate with packages. Nowadays, Python is probably the most popular language in the world. And if you want to integrate with any kind of library, then Python is for you. Java also is a very popular language. And again, if you want to integrate easily with any kind of code that you may already have in Java, then this is the option for you. I'm keeping it in C for now, just to show you the customizations, because our customizations work only in C at this point. And in C, you can choose all these versions of Visual Studio as your IDE, like you can create a project for Visual Studio, and so forth. But these options are all relevant if you are working mostly on Windows, and you can create a Linux makefile, which from its name, it means that it's mostly for Linux users. But CMake, that's what we mostly recommend because, just like Nina mentioned, it's cross-platform, and you can create one project with CMake, and you can then take it to Linux, you can take it to Windows, you can take it to Mac OS, and move it around. And we take care of the compilation changes, almost all of them automatically. So you probably don't need to do too much to make it work on other platforms. And specifically on Windows, you have the NSys installer generator, which means that you can also easily create an installer for your user application very easily with a click of a button. We have a separate video on that on our Academy section of our website, so you can check that out. But for the sake of simplicity today, I'm going to actually generate code for Python. Let's talk about the customizations for a moment. So here you can choose all the customizations that Nina mentioned previously. The Altera IPs, the Lattice IPs, Xilinx IPs, and so forth. And if you choose any of these, then what's going to happen is that your design is going to be included, like your codes or your generated code is going to include not just all the regular functions that our generated code has, but also a special DMA section, which will allow you to run DMA pretty smoothly, assuming that you've worked with the example designs given by Lattice or Altera or Xilinx. Like if you modify things, then of course you'll have to change it on your own to fit what you changed on your design. But in general, even that's much easier to start from a sample that already does DMA with the example design than to start with scratch. So I'm going to choose Python, and I'm going to generate it quickly. And why did I choose Python? Because it's a language that you don't have to compile. So I don't want to spend too much time here on compiling things. I'm going to close the wizard in order to avoid this whole issue with resource overlaps. So yeah, here is the directory with the generated files. We have a special video covering like all the files that are generated, so I'm not going to cover this now, but you can check it out on our website. And I'm just going to run the generated application, which is right here. Yeah, and it automatically opened the device, the same EDU device with interrupt number 8 and the same bars and everything. So we have this special menu item or submenu number 10, which is the registers that I've added in the program using the wizard. So now we see that I've added this manually, and now I can read and write from this register with its own name. So I'm going to write to it in a moment. First of all, I want to enable interrupts. Again, to show you how easy it is to raise an interrupt with this program. Just going to write something to this register number 1. And I'm going to write again 1. And then the interrupt handler here prints that I've got a message signal interrupt. I'll cover quickly other things that we can do with the application. So we can open devices, we can allocate in free shared buffers, manage IPC, inter-process communication between this process and other processes of WinDriver, read and write from the configuration space, just like we did in the wizard. Plug and play, we can reset the device. We can add power events, like what happens when you shut down your computer. You can add sort of like a callback for that. Read, write memory, so that's just accessing the bars, just like we did on the wizard. Enable and disable interrupts, just like I showed. Also, if an interrupt was raised and we've added transfer commands from the wizard, just like I showed before, then it'll also affect what's going to happen in this application. And allocate free memory for DMA. This is just allocating and freeing memory for DMA, but if you choose customization, then you're going to have like much more like actual transfer of data. Okay, so this is the generated code, and it's pretty much the same in all the languages except for C#, the GUI version, because the GUI version is a little bit different. But all of our versions, all of the console versions look pretty much like this, same design and same function name. So it's actually even easy to move between languages. If you change your mind and you suddenly want to work with Java instead of C, then it shouldn't be too hard to do. All right, so I'm going to go back to the presentation to talk about new features in the latest version 16.5. So the first new feature and the most important, the flag feature, I think this version is the addition of the new sample for latest DMA IP by Intel Altera, MCDMA, and in general, I showed you that you can choose the customization from the wizard, and also you can open the sample from the samples subtier that WinDriver includes, the SDK that you download from our website. And we also have a kernel plugin sample for performance gains. So you could, our sample has certain level of performance, but if you use kernel plugin, that it even increases the performance of DMA in some cases. So we've already baked that into the sample, so you don't need to really do anything too special, and it just works out of the box, assuming that you've used the example design from Altera. I also want to mention that if you have issues with that, we have an in-house FPGA engineer, and we have example designs of our own that we can provide to you if you need, like you don't know where to start from. And we can also provide some help in getting started. Another nice feature in this sample is that we have 3 DMA completion modes according to your needs, both calling, write back, and interrupts. and it's relevant to practically all the series of Altera Agile X FPGAs and some of the Stratix 10 FPGAs, but always verify that your model supports this IP first if you want to use the sample. It's more about the hardware design part, but you always must verify that first. Because otherwise, Quartus, like Intel Quartus, won't let you program your device with MCDMA if it's not supported on your device. Okay, the second feature that we have is the mSGDMA IP sample. So basically, in older versions of WinDriver, we had a sample called Altera QSys, and we've renamed it to mSGDMA because that's actually the right name for it and most accurate name for this IP. And it was a pretty old sample written, I think, around 15 years ago, and we revamped it. We added a couple of more modern features like 64-bit addressing, because the previous sample only included 32-bit. And we've added prefetcher DMA features. And this is a great improvement to performance because now you can give a lot of descriptors ahead of time to the DMA controller, and that allows the performance to be much, much better with this IP. In general, mSGDMA is the IP which is the simplest one by Altera, and it's supported by practically all of their devices, old and new. So if you want something that can work on like old and new stuff and is pretty simple, then this is the IP for you. MCDMA, like the previous one I talked about, is the newest and is the fastest probably, but it's much, because it's more modern, it's more complicated. So of course, you have this trade-off. Another very nice feature that we added is some kind of improvement to the Avalon DMA sample, also from Altera. So Altera in the Cyclone 10, Stratix 10, and Aria 10 cards, they usually the best IP to use on these devices for DMA was Avalon or Avalon ST. And basically our sample, what we did is that we enhanced our sample with, like, you can have this checkbox that you can choose from the wizard, and what you can do there is not just use the DMA, but this is a very special sample that not just like we have the basic Avalon version from before, but we also have this enhanced version with EMIF and Scalar 2. What does that mean? It uses these two extra IPs like EMIF and frame buffers and scalars in order to demonstrate how you can actually do image rescaling on an Altera FPGA using WinDriver. So you could actually, we also added the actual project to our SDK. So you can just take our project from the SDK, program your card with it, and see how you can use our driver and our design to actually scale an image. That means like taking a smaller image and turning it bigger, or taking a bigger image and making it smaller using this design. Of course, you can play with it, you can change it, just like you do with any other WinDriver sample. But this is the first time that we kind of, in a long time, that we've kind of created a sample which is not just pure DMA and transfers, but actually some kind of functionality, which is more application of something, not just transferring pure data. So that's a nice example to show and to try out. So I invited you to do so. And on the AMD side, we've also enhanced the XDMA sample, which is our, just like Nina mentioned, our most popular one, by adding a kernel plugin logic. So if you want to have both kernel plugin and XDMA, then again, you don't need to worry about that anymore, because the generated code is going to just be there for you with that. It improves performance in specific scenarios. Again, it really depends on the buffer size you choose and the direction and so forth, and the completion methods. So there's a whole table on the website regarding different scenarios, and of course it also depends on your design. So I don't want to get into specifics too much about when it helps or when it's not helping, but in general, it's a great addition because you can, even if you want to do other things on the kernel plugin, then you don't need to make it on your own. You can just use the kernel plugin provided with the XDMA to add stuff in the kernel mode. Other important things that we did in this version, so we added support for Windows 11 build 26100 and Windows Server 2025. And this is a very important message to our existing customers that older INFs may not work on these newer versions because the change that Microsoft made to the INF mechanism. So if you're using older versions of WinDriver and you're trying to upgrade to these operating systems, you might encounter some issues. And this is why we recommend strongly to upgrade to the latest version, because otherwise you may encounter issues. So the simplest solution is just to upgrade. Also on the Linux side, we added support to newer Linux kernel, newer versions of the Linux kernel up to version 6.14.11. And the last slide I'm going to talk about is changes to DMA contiguous buff lock. In Linux, Linux kernel starting version 6.2 or 5.14 on the Red Hat Enterprise Linux branch. The developers of the Linux kernel blocked the ability to just run, to just lock contiguous DMA buffers. And what happened is that it caused a lot of crashes to our customers on these newer kernels. So what it made us do is to, first of all, just block it automatically, just not allow contiguous buffer locking unless you use this flag in the function, DMA override CMA validation, which overrides the block. I don't really recommend using it unless you know exactly what you're doing, because otherwise you can get like weird crashes with not very clear indications, not very clear explanation why you're crashing. So that's something that I specifically made in order for people that want to use the older methods, but on the newer kernels, if you don't override the CMA validation, then you might have a problem. You might have a problem if you override it, sorry. So what should you do instead? You should use CMA, which practically it means pre-allocation. So you need to pre-allocate the memory from the boot of the operating system, and then it's safe to use and it doesn't crash. And we have a section on the website in chapter 11 in the manual in chapter 11 that explains how to do that. It's pretty easy once you understand how to do it. I think it's about 2 paragraphs of reading, so really easy instructions on how to do CMA. And that's the way that Linux kernel developers forced us to modify WinDriver in order to prevent crashes. So yeah, it's not as nice as it used to be before, I think, in everyone's opinion, but this is a way to avoid unhappy circumstances and kernel crashes in Linux. This is it from my side, and I'm giving the floor back to Nina. Okay, so I see Nina is having a problem here. So I'm going to cover for Nina and talk about the last slide. So how do you get to start working with WinDriver? What you need to do is you can download WinDriver from our website, and you can evaluate free for 30 days with unlimited functionality. You have full technical support during that evaluation. And in the chat, Nina is going to send the download link once she gets back online. So you wait a couple of seconds. And in general, how do you start working with WinDriver? Again, WinDriver is very, very easy, just like I showed you. practically I made a driver in like 5 minutes. Even without any, like I talked a lot and I did a lot of customizations and talked about stuff, but in general, I could have done it even faster if I didn't do that. It exists for over 20 years, very, very mature product with lots of experience and great support that we provide. I think the most important thing to mention here is the sales@django.com. That's the email for any other questions. And I'm opening the floor to questions. If there are any questions that you want to ask in the chat, this is the right time to ask them. And I'm open to answer any kind of question regarding technicalities. And Nina is also back, so she can answer also sales-related questions if there are any.
Yes, if you have any questions regarding updating license or anything else, please ask me. And I was thrown off for a second. I'm sorry for that, but I have something to add. If you liked this webinar, we have very wide selection of educational webinars on our website, as well as very detailed manual that Uriah mentioned a few times. And now I'm going to send the link to our website where you can download WinDriver completely free of charge for 30 days for free evaluation, as well as take a look at our manual and other educational videos. So, any questions? We're going to wait for another minute and let's see if anyone wants to ask us anything regarding WinDriver. Well, it looks like we did such a good presentation that no one has any questions. We did such a great job that we have no questions to answer right now.
Okay, so thank you very much for joining us. And thank you, Nina. And again, I'm showing the email, sales@django.com. And you can write any question over there if you want. And thank you very much. And we'll conclude it by this. Thank you very much.
Let's stay in touch. Thank you very much, everyone.